Hello, everyone. We're going to go ahead and get started with our information session today. We have a good group of you joining us today, and we have quite a bit of information to provide to you. So we're going to go ahead and start our session. My name is Jeffrey Hengel. I'm the Director of Admissions for the Graduate School of Engineering, and I'll be your host today and have some content that I want to provide to you at the beginning of the session and probably at the end. But our featured guest today is Dr. Kal Bugrara, who is the Graduate Program Director of the Information Systems Program. And Dr. Bugrara is going to be giving a very detailed overview of the IS program that we offer. A few introductory notes. Please turn off your microphone and camera. That tends to work best to minimize background noise and distraction. So we appreciate you doing that. If you have questions throughout the session, there's a couple of ways that you can pose those questions. One is you can, well, potentially you can use the Q&A function. There's a link at the, or a button at the top right of your screen, but there's also a chat function. We prefer that you use the chat function to ask any questions that you might have. That could include technical kinds of questions too. If you're having trouble seeing our slides or if you're not getting this audio, that's where we'll be asking participants to type their questions. There are several other staff people that are, staff and faculty rather, that are joining us today in the background, and they're here to answer detailed questions about admissions, about the cooperative education program, and there's other program staff that works closely with information systems students. So this is the team of people that support our IS students, and collectively we can answer just about any question that you might have about the program. We're recording this session today, and we're going to provide a recording of the session to all of the participants and invitees of the session. So if you miss anything, you'll be able to view the recording. Don't worry about taking careful notes. Once again, you can reference the recording later. It might take us a few days or maybe even up to a week to provide the recording of the session. Some of you joining us today actually applied to the IS program, and you're interested in spring 2018 entry. There's some joining us today who are already officially accepted to the IS program beginning in the spring. To those candidates, I say congratulations. You made it through a very difficult and competitive admissions process. For those of you who are awaiting your decision, you've already applied. You should be hearing back from us by mid-October timeframe, so it'll just take a couple more weeks for us to complete our review process. So we hope that you're very much looking forward to receiving your official decision so you can start making plans, if accepted, to join our IS program. But most applicants apply for fall entry usually before January 15th timeframe. So if you're a prospective student, you're thinking about applying, most students are shooting at this point for fall 2018 entry. So we encourage you to apply if interested. Some of you are familiar with some of the slides in this presentation because you've joined us for other sessions. So this is a common slide that we provide an introduction to Northeastern University. We're one of the best national universities in the U.S. We're currently ranked by U.S. News and World Report at 39. In my 8 years at Northeastern, the university has grown by leaps and bounds in their rankings. This has a great deal to do with Northeastern University's reputation, the quality of the faculty, the quality of the programs, and a variety of other criteria are considered in that process. In addition to those other criteria that I mentioned, one thing that plays into rankings is employers' opinion of the quality of our graduates. And so when you see a nice, good ranking of an institution, you know you're going to a quality place. I'll say as an aside, this IS program, the Information Systems program that is offered, is one of the most popular and largest programs that offered by the College of Engineering. Students are so enthusiastic about pursuing this particular degree because it is absolutely one of the best and most unique programs offered. Another reason why students apply to Northeastern is because of the opportunity to pursue industrial co-ops as part of our graduate co-op program. So students can do a industrial full-time co-op paid position for 4 or 6 or 8 months in the middle of their degree plan. And so they get fantastic experience, they can earn a significant salary, and it's something that many of our students are successful in doing. We'll talk a bit more about co-op later in our talk today. Last on the screen is Northeastern has a fantastic career services office. It's ranked as one of the best in the country for several years running now. And all of this means that Northeastern is serious about the career success of its students. Okay, before I move on, many of you know that the IS program is obviously offered at Northeastern's main campus in Boston and has been for a number of years now. The Northeastern University, over the last several years, has created regional campuses at several places around the U.S., and now even there is presence in Canada. So Northeastern has regional campuses in Charlotte, North Carolina, in Seattle, Washington, in Silicon Valley, California, and in Toronto, Canada. And so this goes to the entrepreneurial nature of Northeastern. It's a very innovative place. It's a very entrepreneurial place. So we're not only creating great programs, we're creating opportunities for students to study these programs in places that give them opportunity for networking with employers, an expanded network of co-op opportunities. We essentially put students in the place that they want to be and where they can pursue the program that they want to pursue. So because most students are interested or more familiar with the Boston program, we want to talk a little bit about the campus options in Seattle and in Silicon Valley. So just a couple of slides of introduction to both of those campuses. Some of you joining us today applied to the Seattle program. Some of you joining us today applied to the Silicon Valley program. So we want to say just a little bit about that. So once again, Northeastern University, an entrepreneurial educational institution, looked around the country and looked at places where students would want to study and would want to network with some of the best companies in the world. And Seattle was chosen as a place where Northeastern would develop one of its regional campuses. And so this is a screenshot of the cityscape of Seattle. It's a beautiful city. It's very different than Boston. It's a non-traditional campus. When you walk around the Boston campus, you're walking around a traditional university campus. When you go to Seattle's Northeastern Seattle campus, it's more of a corporate setting. You walk out the door of Northeastern's campus in Seattle, and you're essentially walking around with young professionals who work at some of the nation's best companies. So it's a very different kind of experience as a graduate student attending Seattle versus Boston. The campus profile of Seattle includes not only the IS program is offered there, but 40-plus graduate programs are offered there, where hundreds of students are pursuing their graduate degree. This past fall term, we had between 50 and 60, I believe, new information systems students that joined the program. So they're a few weeks into courses already. And the IS program has been offered there for something like a year and a half or a couple years now. So just like all of our program offerings, the IS faculty has ties to industry, so they're they have a significant job outside of their faculty role, and they bring their expertise to the program. If students pursue their degree at Seattle or Silicon Valley, they can expect what we call concierge student services and support. The classes are smaller, the cohorts are smaller, so students tend to get highly personal support. So as I mentioned, the Seattle campus is a really exciting place. It's a very innovative place. It's a wonderful place to pursue your IS degree because you're able to network with area companies as part of your experience. This is where Seattle's campus is located. It's described as being in the South Lake Union area. You can see, it's basically surrounded by innovative companies, some of the, brand name companies that you've heard of, Amazon and Microsoft, and some of our students are working or co-oping in places like that. So, so this gives you a sense for the kind of environment that you'd be studying in should you decide to pursue your IS degree there. This is a couple of pictures of the Seattle facility. Okay, so moving on then. Our most recent developed regional campus for about the last year is located in Silicon Valley, San Jose, California. And similar to what I said about Seattle, you're not only considering the program that you want to pursue, now you have to consider the place that you want to pursue it in. What kind of networking opportunities do you want to have? What do you want to be doing when you're not in classes and pursuing your degree? Where do you see yourself working in the future? What sort of companies do you want to network with? So Silicon Valley might be the answer to all of those questions. So here's a screenshot of Silicon Valley area and a few bullet points, about Northeastern's presence there. One of the things we like to mention is that this is, different than Boston, different than Seattle. This is a campus that is co-located with an area employer, which is a very large employer, Integrated Device Technology. It's a company led by Northeastern alum, and is part of the, sort of Northeastern partnership, if you will. Okay, so this is a bit of a picture of what Northeastern Silicon Valley looks like. And you can see that, once again, Northeastern chose this location because of the vast opportunities in the STEM fields and because of Northeastern's huge presence of alumni in that particular area. You can see here that 150 plus degree programs are offered in addition to the IS program. Okay, with all that said, let me introduce our featured speaker today, Dr. Kal Bugrara, who's the director of the IS program, who's going to provide an overview of the Information Systems program for you today.
Thank you, Jeff. This is Kal Bugrara. I've been heading the Information Systems program since 2007. We have seen tremendous growth in the program and expansion of our offerings. Now, information systems maybe can be classified more of a school than a department or a program, just because of the vast array of specialties that we have under information systems. We do have presence now in Seattle, and we're starting our campus in Silicon Valley starting this spring, as Jeff alluded to shortly. And there's a lot of connectivity between these three campuses. Maybe I can allude to a little bit later. They're not much of regional campuses, but part of a networked campus. And let me give you an example. We are right now broadcasting a class out of San Francisco to here, live for students to learn. We're planning another class out of Seattle to students in Boston, just because of the tremendous expertise that's available in these two other campuses, making that available to us. Though the programs are still a little bit small in terms of their offerings, we're taking the whole information systems offering to these campuses as well. Next. All right, so I'll give you a little bit of a feel where things are and how we're responding to the challenges in the marketplace, and so we can position IS correctly. What we see are definitely businesses are going digital. Digital businesses creating new ways of generating revenue. Small players are chipping away at a stable source of revenues for big players. You can see that with the banks. People are developing small payment apps where you can transfer money in a few seconds instead of having to wait 3 weeks to receive your money. And this is worrying big banks big time. Being nimble and agile is the way to go. Technology and data are the foundation of making good decisions. Social change can benefit from technology, so things like e-government, e-health, and the environment issues that are now being addressed using technology. And at the heart of all of that, software engineers are going to be the center of the next revolution. So for us at Information Systems is how we produce the right kind of software engineers to be able to respond to these challenges coming our way. Next. And the things you hear out there, machine learning, big data, Internet of Things, virtual assistants, autonomous vehicles now becoming a piece of software, virtual money, artificial intelligence, robots, and virtual reality are big buzzwords these days in the marketplace. What do these things mean? What's the role of an information systems engineer in these big thrusts that we see right now coming our way? But the big news of them all is the tremendous acceleration of technical innovations like we've never seen before. So it's not so much that things are moving fast. Even the acceleration, the rate of change in technology is, is being sped up quite a bit. So change is a big part of what we do. Information system is very nimble, fast changing, and dynamic to the demand out there. Next. Who we are located at the intersection of cutting edge technology and business complexity. The information program, we offer a master's degree for engineering professionals seeking to advance their studies in this exciting field. One important facet of what we do that makes us very special and unique in the information system software engineering world is our socio-technical approach to engineering software systems for solving complex real-world problems. And I'm going to elaborate a little bit more on that. And that's part of our approach. Right, next. So one simple way of explaining what information is to look at the intersection of these three circles. One facet of what we do when we build our applications is business complexity, the world we try to automate, the software engineering techniques, programming, algorithms, what have you, Java, whatever. And the third facet is IT management, the ability to understand the impact of cost, quality, and time on the engineering of software systems. Our preference is for our students to build skills in these three different categories to make them, very competitive software engineers, right? So we follow a socio-technical paradigm to solving complex real-world problems in this respect. And next, I'll show you some of the courses that we offer in each of these categories. Next. For example, some of the classes, and we have a lot more we'll show later, business analysis and information engineering on the business complexity side, how to understand the requirements, how to write requirements, how to engage the client and communicate well and effectively. Business process engineering, being able to re-architect the way businesses run to make it more nimble. One fundamental concept in the business process engineering class is how to come up with performance measures and targets and be able to get the necessary metrics to be able to veer your business the right way. Organizational change and IT class that gets into psychology of change and helping our engineers build the skill sets so they are effective agents of change to bring about new way of doing things based on innovation and progress. Healthcare service delivery class that gets into the healthcare issues and for our students to understand the healthcare market and being able to prepare themselves for a career in the IT healthcare area. Design and engineering of financial systems for financial fraud, data analysis, data mining, and being able to detect anomaly in the financial systems. User experience design, I'll talk more about this, being able to understand the user requirements and the best way to visualize what the user is looking for. On the managerial side, the planning class, the enterprise architecture, software project management and quality assurance, IT auditing, planning big data project, and managerial communication for engineers. These are some of the classes that we're offering on the IT management side. One of the most important condition for becoming an IT leader is definitely communication, the ability to interact in a proper way, at the right level, at the right time, with the right people. Next. So on the technical side, you will hear a lot about our application engineering class, a very unique class, how to design software the right way and see them through full implementation. Students spend the full semester going from minimum knowledge in programming to suddenly being able to build complex software systems using Java programming, user interface design, object-oriented design techniques, UML standards, and the like. Right? Web methods and tools, smartphone development, security classes, big data, cloud, algorithms, natural language processing, virtual reality class that we have taught for the first time actually this summer, and more of the virtual reality work line that you're going to see more of in the coming semesters. Of course, on the data side, being a data engineer is a big thing these days that involve data science classes, cognitive computing, neural nets, deep learning, and advanced indexing techniques. So this gives you just a highlight of the different courses that we have in these three different areas. To us, for a software engineer, there's a balancing act here, being able to select classes that will balance all these three areas to be an effective software engineer. And one simple definition for us is that we call our program programming with the purpose. Being able to learn programming, being able to develop applications using different programming techniques to satisfy the business need or the business requirements the right way, instead of being able to approach programming in an ad hoc way with no purpose. I think this is pretty much what makes us different from your typical computer science engineering program. So industry needs, as we see them in the market these days, and we always in tune with what's happening in the industry. User experience design and development is a hot area. As you know, machine learning is a big thing. Big data engineering, being able to handle all those huge, gigantic amounts of data is a big issue. Natural language processing is becoming an important area right now. In fact, there is more text to be mined than structured data right now. And understanding the parsing techniques for natural language processing is a big thing. And now we offer a class in this domain. One of the project students were working on in this class a couple of semesters ago was being able to parse complex contracts and being able to extract data out of the legal language that exists in some of these 200, 300-page contracts. And students successfully were able to index these contracts and be able to mine them for the kind of intelligence necessary for lawyers to understand what these companies are obliged to do and what rights do they have and so on. Cloud computing class is definitely, there's a huge demand for cloud computing. More concentration on programming skills is also, there's a huge demand for that. And there we have the algorithms class. Java, heavy emphasis on JavaScript is also needed. Scala programming is highly in demand right now. Haskell is becoming very popular, and the latest of them is Go. Right, so how do we respond to these? So like I said, we have different courses in these different areas to help with this. Next. So this is what companies are facing. Huge amounts of data already exist, must be properly leveraged for competitive advantage. New generations of applications that consume the data and produce smarter insights. And this is pretty much where artificial intelligence is. The challenge is how to build for such a gigantic scale, global, multiple enterprises and agencies collaborating to get work done. Design definitely is the way to go. A very complex set of skills are needed. Programming, design and architecture and communication, people skills is also is a requirement these days for any software engineer. And we respond to all these demands, as you will see in our broad offering. Next. So this is who we are as an information systems program. We have the technical skills. Definitely, we are different from what you consider management information systems. We are part of the College of Engineering. Historically, we have been heavily on the technical side of software. So, however, we do offer multitude of courses, what we call people skills, managerial nature, as I explained earlier. That includes the business analysis I mentioned, project planning, organization, agile development, financial systems, communications, and the like. On the technical side, we have over 30 different topics that we offer in our program in these different categories. How to build applications the right way. We have a number of courses in that domain. User experience engineering is a huge for us. Mobile computing, machine learning and data science engineering, cloud computing, big data engineering, cybersecurity, virtual reality, and digital business is very much the softer focus area that includes enterprise architecture classes, business process engineering, IT auditing, and the like. Business intelligence is another area, cognitive computing, and the latest comer is definitely the blockchain, where there's a lot of excitement from our teacher side and our student side to grow this domain that's expanding very fast. And this is one of the key areas that we are emphasizing in our Silicon Valley program. The emphasis on blockchain, smart contract technology, especially for the financial services area. Next. So engineering of big, definitely would, I think one of the biggest contributions that we've made over the years is our ability to take engineers of different backgrounds, communication, mechanical, signal processing, bioengineering, and being able with minimal programming knowledge and be able to turn them into first-class software engineers. This really has been our specialty, being part of the College of Engineering. We always serve with engineers of different backgrounds to introduce them to the software engineering world the right way. So our approach has been very unique, very different from the typical approach you find in computer science that is based on building things, building them the right way according to specs, and being able to deliver things that have utility. So utility is an important concept in what we do, but our ability to take a water engineer with zero programming background and the step-by-step way turn them into amazing software engineers working for Google or Amazon is something we do very well, right? So this is probably the biggest thing that we can emphasize. I see some of the queries that are coming my way here. Students are asking whether programming background is necessary for admission to IS. No, it's not, but it allows us to profile the right path for you, how you should approach your classes. But I tell you, in our application engineering class, which is the only core class we offer, the remaining classes are very much electives, is the ability to have amazing engineers coming from different backgrounds, following a very powerful design methodology, be able to produce super complex systems, right? So programming is not a requirement, but we do want you to be receptive to learning how programming works, right? So we're not expecting a student to become a heavy-duty programmer. You could make sure, having taken the fundamental programming classes, that you can move to a managerial role or emphasizing the managerial classes that we have in the program. So that's a necessary requirement. Other than that, we're more than happy to take engineers of different backgrounds and work with them in that domain. So this is the engineering of big data systems track. So I'm going to talk to you about the different tracks we have in the program. Like I said, information systems is really a container program. We have so many courses and your ability to navigate the program different ways is something that we encourage quite a bit. And we're going to show you the different tracks or guidelines we have for our students, how to specialize. For example, when you look at the engineering of big data systems track, what's required there, or what we recommend for our students, is the network structures and cloud computing class. The teacher there is one of the first people to work on the Watson system out of IBM. He's an IBMer, heavy specialty in cloud computing, and this is one class that we offer in that domain. Very critical for which additional cloud computing classes are coming as well. The big data engineering class using Java, this is a functional programming class that emphasizes sophisticated programming techniques to make it easier to build big data systems, where the emphasis on concurrency is reduced quite a bit. So very powerful programming language that we encourage our advanced students to take. Concurrency and multi-thread programming is essential for a heavy-duty developer. Big data systems and intelligence analytics, this is where we teach deep learning, and there's a lot of emphasis on projects in healthcare or what have you, and involve as well as natural language processing and deep learning. This is what we do in that class right at this moment. Of course, the big data class that emphasizes Hadoop and all the tools that go around it, how to put a huge big data pipeline that involves data cleaning, organization, indexing, and the like. Next. User experience design. This is for those of you who are interested in focusing on the client side of engagement. User experience design and testing. This gets into the look and feel, user interface understanding, user requirements, being able to do mockups, and the like. So the person teaching this class is coming from the MIT Lincoln Labs, which has a strong ties to the US military as well as IBM. So there are amazing user experience methodologies being discussed in that class. The final output there will be user interface designs mocked up in one of these design tools. The web design class emphasizes JavaScript, E6, E7, and now E8, and web components are being discussed in that class, as well as HTML and style sheets. Right? Engineering of virtual environments, this is an advanced class that we started offering, like I said, this summer, and it's been an amazing success and amazing experience for our students. So this is an emerging area for future, what the future user interfaces will look like. Agile software development class that emphasizes how to work effectively in a team, planning and managing information systems project if you want to learn how to do a project for an IT. And again, managerial communication will help with the client engagements and business analysis and information systems. And information engineering emphasizes the additional client requirements work, understanding the software life cycle and the like, especially for those who are not familiar with the IT field. So we always like to take them into this class as an introductory way of understanding the software life cycle. Next. So this is a familiar area for many of you, business intelligence and data analytics, that emphasizes the borderline right now between data, business intelligence, and the big data platforms of the future. So one of the teacher that's teaching our business intelligence class is a book author, and he's at the forefront of the bridging the gap between data warehousing and big data platforms, and he's addressing those things very effectively right now. As you see, we're encouraging students to take the business process engineering so they understand where the business intelligence requirements are coming from the way you want to measure your processes. Understanding how that area works is fundamental. Next. Cybersecurity, that goes without saying. You know, we have an amazing guy teaching one of our cybersecurity class that used to be a CIO at State Street here, one of the biggest institutional banks, and he's delivering the cybersecurity class. We always emphasize the software security inside out ourselves. We have a distributed security class, The IT auditing class is very important in this space. And natural language processing is another area, being able to parse natural language for potential threats. And students need to understand how to use natural language processing to create alerts when incidents happen. There's so much danger in the language itself that requires that we parse the language and be able to detect the threat that might be in the chat or communication between people, right? So also we emphasize the cloud computing class, and in fact right now there's there's an alignment between the way we teach our IT auditing and cloud computing. So actually one of the teachers that's been involved in teaching the cloud computing is the one teaching the IT auditing, and the question of how to audit software systems within the context of a cloud environment. And a cloud is now becoming more fundamental, essential for any company. It's not the outside versus inside anymore. It's coming out to be that maybe public cloud is a lot more secure than your data inside your bank. So there's a huge shift right now within banks and other companies to just accept the cloud as a fact and go with it as a much better way to manage your data than having to maintain your own servers in the cloud. So there's a major shift going on right now with more emphasis on public cloud as a safer, more secure, more cost-effective way of managing your systems. Next. Of course, mobile computing, essential within that context. There's only one mobile computing class that we teach that emphasizes the front end, be it Android or iOS. And with that, of course, we have the web development methods and tools that provides back-end support for mobile platforms. The web design is heavily emphasizing responsive designs, different ways of designing, using JavaScript to build mobile apps as well. Okay, we recommend there the virtual reality class and the agile software development. Of course, the virtual reality is now finding its way to the mobile devices as well, and we need to understand how that links to the smartphone development. Next. Digital business, for those of you who want to have a career on the software side of things, to become an IT manager one of these days, or to be a system analyst, junior to begin with maybe. For those of you who already have a career in IT and it's about time to move to a managerial role, these classes are for you. Planning and managing information systems, how to do a budget, how to do a funding model, how to understand the different tasks and steps, the epics and the stories that are involved in your information systems, and how to cost the delivery of effort. Business process engineering is a very important class there, organizational change in IT, enterprise architecture, planning and management, and this is where we get into portfolio management when an enterprise is going through a change or trying to become digital. What are the portfolio of projects that are necessary to move the enterprise to being a digital enterprise? IT auditing classes also emphasize it there, because understanding risk platforms and how to measure and prioritize your risk and be able to manage mitigate whatever could go wrong is an essential component in being in the digital business space. And one important class there, which is really very special to us, is the question of how to manage big data projects. And architecture and governance of big data systems is the class for that purpose. We created this class a couple of years ago, taught by one of the most amazing people in management, in IT management, a person who built his own tool for handling all the resource management around IT projects. In fact, his tool set applies to any kind of project. So he pretty much figured out a particular technique how to deal with these big data projects, and being able to take that class will put you really in a special position in the business analysis, system analyst type space, if this is the way you want to go. Of course, the communication class, the managerial communication class is also encouraged to be here part of this program. But these are the classes that you need to put yourself in an IT managerial space. Again, we emphasize that you still need to take the application engineering class as a fundamental building block for all these classes. You need to understand how to put the system together, what's involved in programming. At the end of that class, you don't need to be a professional developer, but you need to understand how programming works. You know, for you to be an IT manager, you need to know what software engineers go through to build their software. So we feel there's enough substance in the application engineering class for you to build the foundation, and then you can move to the IT managerial role if you choose. Right. Next. Full stack development. This is one of the most popular tracks that our students prefer, and our employer partners care about most right now, from students, especially those who have an international background: application engineering and development, cloud computing, algorithms, web development, concurrent multi-threading, web design and user experience, cybersecurity class, and preferably the agile class to go with it. So this is for anyone who's technically oriented and want a safe route or success. This is the most popular track that people care about, right? But our students are really very diverse in these different tracks, right? Next. And of course, it goes without saying, machine learning and data science engineering, you know, one of the hottest area right now. We recommend the algorithms class to start with, machine learning class, the big data systems for deep learning, how to create a huge, large-scale big data pipelines on top of Hadoop, natural language processing using Python is something we teach, and now the world of deep learning, where we have a cognitive computing class that gets quite rigorous into the neural net world and how to use it, how to use neural nets to build for recognizing complex concepts. Right. Most of the emphasis, at least the class, the way it's running right now, students are combining natural language processing and neural nets to be able to make sense out of language. Now, one of the areas that, and of course, this is the blockchain and smart contract is where we have the, you know, personally have quite a bit of excitement here, and this is the major thrust that we're going to have in Silicon Valley. We have two classes running, the cryptocurrency class and blockchain engineering, where it gets to the fundamentals of Bitcoin and how things work, the security involved and the like, and then the other class that we're running right now, smart contract application engineering and development, and I'm personally teaching this application engineering class myself. The class is in its fourth week, and one of the teams already have an idea for a project that's going to lead to a paper at the end of the semester. You know, I'm not going to stay away from saying what the domain is, but this is the potential for our students. They're working in the healthcare area, and they found an application that nobody built before, and I'm guiding them through that process among everyone else. And we're looking at additional applications in the financial domain where it could benefit from blockchain engineering technologies. Some of our students from the spring batch ended up working for IBM. They're in Austin right now, building, converting their supply chain products to blockchain-based supply chain products, right? So, and interestingly, the cryptocurrency class is coming out of San Francisco over a live link taught by a professor with an MIT background as well as computer science out of Stanford. So this is an example where we bring the know-how to our students no matter what, and that's how I see IS as a interconnected campus for knowledge sharing and exchange of ideas. as an example of a class that we're offering next semester is somebody will be broadcasting a machine learning class out of Seattle to our students in Boston, and the focus on the application of machine learning in healthcare, where the vision for this leader, technical leader, is within 5 to 10 years, we don't need doctors. The system can diagnose whatever disease the person got. So this is the boldness of the people that we bring to the program, and you're going to be exposed to the latest in terms of thinking and what's coming in the future. But definitely blockchain engineering is a very significant area, and the key thing here is there's so much security and safety controls exist in a blockchain platform that it's going to make it much easier for us to build super complex, safe, and secure application with minimum effort, assuming we understand, we get the necessary training how to leverage blockchain technology correctly. So students right now are using Uport, are using Web3.js, are using Meteor, are using the Quorum blockchain, the Ethereum, the Test RPC platforms to build amazingly complex blockchain applications, right? So we do see the blockchain as a certificate of some sort for those students who already have technical background and ready to move to something more complex. Still, I see a lot of emphasis for students with no programming expertise will be able to follow the other track, being able to take the application engineering class, the algorithms class, maybe the web development class as well, or the web design classes, and be able then to switch to blockchain technology. This is probably the hottest area that's out there at the moment, and we're making sure our students have the necessary preparedness to respond to this demand, right? So to give you a feel for what we offer first semester to our students, so this is what we recommend to our students, usually the application engineering class. This is where you learn object-oriented design, being able to tackle complex problems from a design to implementation, and then you couple that with either the business analysis or the Java programming class. The algorithms class is an option, data management is an option, web design, heavy JavaScript programming, or the data science class. This is something we're offering for the first time, allowing our first semester students to start on the data science track as well. So now still within data science or within machine learning, deep learning and the like, with the emphasis still on how to be a good software engineer that understand what's required to put the machine learning application together. Because at the end of the day, we're not interested in our students becoming mathematicians as much as being good machine learning engineers that know how to build systems. So still the emphasis on putting systems together and not necessarily try to mimic what it's like to be a physicist or a mathematician. So the trick here, you have to understand that about 80–90% of machine learning, data science, deep learning projects the effort there of over 90% is going to the data pipelines. So being a good big data engineer is really fundamental to the efficiency necessary to deliver on machine learning. So I've seen mathematicians that were hired to do data science, machine learning, that ended up spending most of their time having to address the data. This is where our students have the most efficiency and most influence on machine learning projects, being able to handle it as a system problem that has all these mathematical foundation stuff that's going on. So our students still take the machine learning class to understand the theoretical foundations, and Python is a big deal in that class, and being able to put a full application together is what we do. Of course, managerial communication could be a start for some of those students who are on the softer side. Organizational change is an option. So you can see just by looking at the second class that we are addressing the needs of the different profiles of our students coming in. So if you choose, you prefer not to be heavily technical, then there are these softer classes that you can start with. And I've seen that in our students over the years. a little bit scared of programming at the beginning, but slowly they adjust and get more and more comfortable, and by the end they become just first-class software engineers. Others would like to jump to heavy programming right away. There are those who are just enough to move, want to do enough programming to be effective in the business intelligence area. And of course, when students get a sense of the kind of jobs you can get on these technical routes, they start getting more encouraged to focus on programming. Right, so starting salaries for some of these kids in the Boston area is between 85 and 110 right now, especially for good heavy-duty software engineers. So the program has been in existence since '81. We're very different. There are only 2 information systems programs that are part of the College of Engineering. It's us here at Northeastern, as well as Johns Hopkins, right? Everywhere else, it's usually called MIS, and it's part of the business school, and sometimes when information system is part of the computer science, it's a watered-down version of some kind of a managerial something, which never leads to anything. But being able to be technically fit, in my view, even for those of you who have programming experience and been building applications, this program still can be very valuable because of the new thinking that we bring to what we consider software engineering. Right. This is what typically students do for semester 2. Web development is very popular. Algorithms, data management, and web methods and tools. The emphasis there will be on Spring and Hibernate on the back end. Angular 2 is also being taught. Again, JavaScript web design is heavy emphasis on E6 right now, JavaScript. And web components is becoming a part of the class as well. So web methods and tools for data science. So these are popular tracks for semester number 2 because of the emphasis on being preparing oneself for a co-op position starting in May. So if that's not a priority for you, then you can be a little bit more lax, a little bit softer with your classes. But many students would like to start their co-op experience starting in May, and for that, this is the behavior that we see, or the options our students select, right? So definitely, this is a very flexible program. You can, design your program as best as you see fit, and these are the guidelines how we think the market is going to respond to your needs. So, and you have to understand, the Boston area right now, especially, I don't need to say much about Seattle. It's the software, it's all software industry. Silicon Valley, it speaks for itself. And Boston is achieving tremendous growth on the software engineering side. As you know, GE is opening a huge IoT center here, and they're going to be a lot of need for software engineers. Facebook is expanding, Google is expanding, the bio industry is thriving in the Boston area. So there's just plenty of opportunities for you if you decide to join one of our 3 campuses here. And of course, you will have the ability to move between these 3 different campuses fairly easily, just filling a form of some sort and being able to switch campuses as well, still the same degree. And thank you.
Okay, Dr. Bugrara, thank you for that overview of the program. There are a few program-related questions, which I'll facilitate a conversation with Dr. Bugrara on in a moment. It's about 5 minutes before the top of the hour. Probably will go about 10 minutes late today. I'm hoping that those of you joining us can stick around for the duration of our session today. A lot of students apply to Northeastern University for the opportunity to pursue graduate co-op opportunities. A co-op is cooperative education. It allows students to get career and academic-related experience as they're pursuing their degree. Usually students are doing co-op in the middle of their degree, so they're in their courses for their first couple terms or year, and then then in the middle of their experience, they're pursuing or they're competing for co-op positions. There are hundreds of Northeastern graduate engineering that get co-ops each year, and there's an entire network of faculty that support student success in this particular area. Co-op is a competitive program. Not all students that want positions will be successful in getting positions, but a great many of them do. And those that do, which is a very large percentage of IS students, will earn a significant salary that can help to defray education costs. So the first step for students who are admitted, who pursue their IS program, will take a co-op preparation course in their first or second term. And I'd like to say that co-op is career preparation. It's one and the same. If you're successful in getting a job offer, if you're successful in admittance to a graduate degree program like the IS program, then you can be successful in finding a co-op position as part of your degree program. So, you know, the students who know themselves, who know the industry, who are active in their co-op job search, who take advantage of any and all resources, are the ones that are successful in getting a position. Co-op is not required of students. Some students choose not to pursue co-op as an elective course option because they want to graduate quicker and they want to enter the job market. So it's presented as a program option, certainly not as a program requirement. So one thing I say about co-op is that if you pursue your degree at Northeastern as opposed to other schools, in addition to the faculty and staff that are supporting your success, you have a network of co-op faculty who support your success as well. We have one such co-op faculty member joining our session today, and so if you have specific questions about the cooperative education program, please feel free to use the chat window and type them in, and we'll have the best person answer whatever question you have for us. But your co-op faculty member teaches your co-op preparation course, but they're also your partner, your sort of trainer, motivator. You have an additional sort of faculty member who's supporting your success in the program. Okay, a couple of slides about investing in your career. Pursuing your degree at Northeastern is a huge investment, actually, in time, energy, and money. The tuition this academic year is $1,523 per credit hour. MIS program is 32 credit program, so you can do the math on what the tuition costs would be. If you pursue co-op, that's that's billed as a 1 credit course, so that would be 33 credits. So you can add another $1,523 to the tuition bill. Students pay about $500 per year in fees, and full-time students are required to have health insurance. Most students will pursue the Northeastern Health Insurance Program, which is at around $2,100 per year. So this gives you a sense for what some of the education costs would be. Sometimes we use a figure of around $70,000 or $80,000 as the total investment, personal and academic, to complete your degree at Northeastern. It's a significant investment. It's an investment that aspiring professionals make because of the return that they get. They get the career and the job that they want, developing knowledge and skills, and the linkages to the field that Northeastern University can provide. So when it comes to financing the degree, there's very little scholarships or financial support that Northeastern University or the Graduate School of Engineering provides. So the vast majority of students finance their education entirely through the use of personal and family funds. A lot of students taking educational loans to pay for their educational costs. Hundreds of students, as we said, will be successful in getting co-op positions as part of their degree. If you do the math on that, a full-time co-op position for 4 or 6 or 8 months at an average of $25 an hour, if you do the math, it averages to thousands of dollars that you're earning as a cooperative education student while you pursue your degree. It's a competitive program, though, as we always remind students, so it can't be considered a guaranteed source of finances while you're pursuing your degree. Most students also work while they're working on their IS program, and so even international students are successful in finding part-time work on campus. One thing that we definitely want to emphasize today is that the Silicon Valley program this coming spring will be our inaugural class. And so if you're admitted to the IS program, you'll have a choice to choose what campus you want to pursue your degree on. So if you applied to Boston and you're admitted and you tell us you're interested more in Seattle or Silicon Valley, we can, most often, we can change your campus preference and accommodate you there. Because of this inaugural class this coming spring, we're fully anticipating that we'll have plenty of student interest, and we'll be able to launch our inaugural class. And so within the next few weeks, we'll be deciding about what our class is going to look like and how many students will comprise that inaugural class. Hoping for somewhere in the neighborhood of at least a dozen students, but maybe as many as 20 as part of that initial cohort. So this is common. We're trying to get our Silicon Valley program off the ground. It's a fantastic program. It's a wonderful opportunity. We are offering as an incentive to admitted students that pursue their IS degree in Silicon Valley a guaranteed 25% tuition scholarship. So that's a 25% tuition discount on the tuition costs. So full tuition costs to complete a MS degree, if you take that 1,523 figure times 32 credits, is somewhere in the neighborhood of $48,000 US dollars. Those that do their degree in Silicon Valley with 25% tuition scholarship will pay about $12,000 less. So it's a significant savings in your tuition costs for students that end up pursuing their degree in Silicon Valley.
And Jeff, just want to, I have to get to another meeting, so there's a question about whether the courses in the 3 campuses are going to be the same. Absolutely. However, since these are expanding campuses, we're bringing these courses gradually, one step at a time. But definitely the programs are intended to be on the ground. When there's a sharing or collaboration between 2 teachers across campuses, then we will use video links for communication between the professors. But this is one exciting area that we would like to emphasize more, is being able to take expertise or bring expertise to our students wherever they are, right? But definitely the same quality. In fact, you know, we found amazing resources in Seattle in the machine learning space, like I mentioned before, that is just going to be so enriching for our students in Seattle. The teacher that's teaching the machine learning class in Seattle right now is one of the research scientists at Amazon, right? Delivering machine learning capabilities for Amazon. So this is how things are. So yes, the plan is to take all the courses and to have them as big as we have them in here. However, the transition is definitely being gradual, and we're not offering hybrid courses for for Seattle. All our courses are on the ground. There are some online courses that are being offered in Boston for our students on co-op. These are also available to students out of Seattle or Silicon Valley in the future.
Okay, thank you, Dr. Bugrara. It sounds like Professor Bugrara has some other commitments this morning, so we, this morning here in Boston, for some of you it's late in the evening. Thank you for that program overview, and you can feel free to get in touch with us or with Dr. Bugrara directly if you have other questions that we weren't able to answer today. Okay. We encourage you to explore these program options and these campus options. Go to the Graduate School of Engineering website, spend some time getting familiar with the IS degree program, visit both our Seattle and Silicon Valley campus pages to get more familiar with the campus, to get more familiar with the IS program offering there. Most of those regional campuses will have links that relate to new students or prospective students. So they'll talk a little bit about housing. They'll talk, about other kinds of services that they provide. Usually, you'll have an opportunity to join a Facebook page, or in order to interact with currently enrolled students at those respective campuses. We can actually even put you in touch with students who are pursuing their degree in Seattle, and probably find a way for you to connect to students in Silicon Valley if you're interested in getting the student perspective, which you certainly should. Some of you went to other webinars that were specifically about Silicon Valley, and we expect that a couple more webinars will be presented. So if you have questions more about that particular opportunity and that campus, you'll have other opportunities to learn more. So let's take a couple more minutes to see what questions you might be posing to us on the chat window. We'll just spend maybe 3 or 4 minutes answering questions before we'll close our session, because we want to reasonably stay on time today. So let me turn off my microphone here for a second. I'll record a handful of your questions, and we'll see if we can answer those before we conclude our session. One of the questions that we have on the chat window here is the idea of transferring from one campus to another. I'll draw a little bit on our experience working in Seattle. There were a handful of students that began well, it's gone both ways. They begun their program in Boston and then wanted to finish their program in Seattle for a variety of reasons, either because they had family or friends or other personal reasons for wanting to do that, or they wanted to pursue their career, following graduation. So that has happened in the past, where a Boston student will switch to Seattle and vice versa. And we're anticipating being able to support those kinds of requests for students that begin in Silicon Valley and want to complete in Boston, or vice versa. Usually we're going to ask students to complete at least 2 terms in their degree program before they petition to change campuses. So we anticipate being able to support those kinds of requests. We have a I-20 related question. I-20 process pertains to usually always international students who are pursuing an F1 visa to attend their program here in the U.S. If all the other things being equal, if an admitted student initiates the I-20 process today, they'll receive their I-20 in the mail about 4 weeks later. So it takes about a month. So we hope that all of our process will conclude by mid-October. Students will have about a month between mid-October and mid-November to initiate the I-20 process, and then most students will receive their I-20 before mid-December timeframe. So spring term is a very tight cycle, but we do our very best to expedite I-20s for admitted students. Okay, so in the interest of time then, let me conclude our session by thanking you for joining us today. We hope that you learned a lot. For those of you who are admitted already to IS, you know now that you have the option of choosing your campus preference or changing your campus preference. So send us an inquiry if you're a Boston admit and you want to Silicon Valley or Seattle. If you're a Boston admit and you want to express interest in Silicon Valley, please let us know. For the rest of you who are applied for the spring, we wish you the best of luck in this competitive admissions process. You'll know your official decision by mid-October timeframe. For some prospective students that joined us today, we encourage you to investigate this program further and to apply if interested. So for all of my faculty and staff colleagues joining us today, we thank you again for joining us, and we wish you a great rest of your day. Okay, goodbye.